What's up, everybody? Welcome to another episode of Tech Talk, powered by P&L. I'm Matt Source. I am the P&L Advanced Services Project Supervisor, and today I am with my good friend, Jared Keister. He's our Welding Technology Department Manager, as well as our Special Inspection Supervisor. So today we're going to be sitting down, we're going to be talking about bolt testing, so everything to do with the Skidmore, lot testing. We're going to go over some bolt demo stuff for your bolt crews, and yeah, we're going to have a fun. I'm sure it's going to be actually a very fun one. So the Skidmore, Jared, let's talk about the Skidmore real fast.
All right.
So what do we put the bolts in, we assemble it. We're gonna grab one of these bolts real fast, right? Go in there. Not that one. You don't like that one? Yeah, I like that one. Use this one. So you go through, you assemble it. Make sure you use your washers. Make sure you put it in the right way. Please read the manufacturer's instructions. It's always the best. And then once we start taking it up and we start putting a load on there, what's actually happening with the Skidmore and what is it telling us?
So the Skidmore is used to measure clamping force. So when we do our tests on this, our lot test, we have to make sure that each bolt makes its minimum required clamping force. Okay. So there's a couple different ways that we can do that. We can do, simplest is turn of the nut. You have a required number of turns for bolt diameter. We have calibrated wrench, which is we use a wrench, we find a torque, and we install them that way. Or there is a Lejeune gun or a TC bolt, and that automatically tightens it. And when the Lejeune gun, what it actually does, right, it puts a load on the actual tip and it twists it. It actually breaks it off into two separate pieces. And yeah, right? Yep. So let's do a quick demo on how the Lejeune gun kind of works and everything. Find a nice little bolt. And what size bolt are these, Jared?
This is 7/8 by 2 1/4 bolt. And what grade?
A325. So we put it in the back, tighten it down.
Before we get there, I mean, what are we looking for as, you know, we start putting a load on here? What's our intent to get happening?
Well, there's a minimum required tension value that we have to achieve.
Okay. Now let's look in the book. Please always have a code book with you. It's better than using memory.
So for a 7/8 bolt, the minimum required pre-tension is going to be 41 kips, so 41,000 psi.
So then, but if we're doing a lot test, then we're going to actually add 5% on top of that?
That's 1.05 times the installation torque. So the installation torque is 39 kips.
Gotcha. So our 41 is actually what we're looking for when we do the lot test, but actual installation torque would be the 39 kips.
Correct. 41 is for the pre-installation verification.
Okay, which would be a lot test. Alright, so we go through, we assemble it. You'll see on your die these nice lines on here. So you see the red line is for A325, so we're going to go to a 7/8 bolt, so 39. Plus, we're going to go a little bit farther over to the 41 to make sure our lot test is valid.
Correct.
Right? All right.
So we have it installed. Before you do any pre-installation verification, you have to actually snug tight it. You have to use a wrench, and you have to wrench tight it before you actually start the test.
Now, what's the definition of snug tights?
Wrench on there.
We generally recommend going up to about 10 kips or so.
Yeah.
Or 10,000 pounds.
Correct.
Okay. So what we'll do here, we throw on a handy dandy TC gun.
And you just go until it stops.
Well, there we go, boys and girls. This is exactly why you do a lot test. So what happened was it came all the way up, and the TC, the NTC part, is it hot? Yeah, it's toasty. So what we want to show here is on the TC part, our nipple never fully splined off and broke off as it was getting twisted by the gun. So it came all the way up to its maximum elongation, never wanted to break, and then this is the result. We get a failure which would be a failure out in the field while you're trying to install it. So now that we had a failure, we saw what happened. So we take it all the way up, it broke. We now know that that lot is bad. So hopefully we got a good one for you guys and we'll try this again. We're on, put on a snug tight. Let's try this guy out. Alright. Okay. So it's all there. We ended up taking it up. Came all the way up, came well past our 41 mark, all the way up to about 55, which is pretty common for TTC bolts.
Yeah.
They usually do snap about 100 or about 10 higher, 10 kips higher than normal.
Unless there's an issue with the bolt, they will always go way over the minimum recommended.
Exactly. So this would then, you would record down your kip value, and that one bolt's good. So generally in lot tests we do 3 bolts per lot.
3 bolts per lot, and it's for every grade, diameter, length, and lot.
Yes. So now theoretically we would go through, do 3 more of these, and then that lot would either be good or bad to be used actually in installation. So break this guy off. Sweet.
One.
Blah, 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 blah.
One.
Alright, go lot bolt number 2. Yep. So, failure number 2. Now what we have is a stripped thread. What happens is it's going around, the nipple's not breaking, but instead of having a complete shear off like that, it actually goes through and just rips the threads right off of it. Which becomes very difficult to deal with because they generally don't want to back out at this point. The nut's on there and it's all tight and seized down. So unfortunately,
grind it off.
Somebody's got to grind it off. Alright, welcome back. So we got that bolt cut off. Were we able to see the sheared off point? Or were we able
You're
to get
not. It's stripped internally.
Stripped internally inside of the actual nut itself.
So I actually had to go through the cutoff wheel and cut it.
Very nice. Alright. Try one more TC bolt and then we'll go over and start doing some lot test, some bolt demo stuff with turning the nut and calibrated torque wrench. Now we're back to normal. Everything's all good. We came all the way up, passed over our 41 kips, ended up taking it off, took our spline off. Everything's all good. And next, I'm going to show them the cut spline. Cool. So we got to swap over to the 3/4.
Correct.
Correct.
Hex head. 3/4 hex head.
3/4. As you guys can see, it's pretty easy to, you know, put on a different size bolts, shank and everything. Washer. Alright, Jared, so which one do we want to do first?
We will do turn of the nut.
Turn of the nut. You have a paint pen? You do, you do. There you go.
So what I put on here was a standard spacer. These you can purchase these, and what they do is they make sure that you don't shank out your nut on the shaft of the bolt.
There, let's get a little close up to that guy. So you've got your shank and then your threads and then your end. So if we were to just put the actual nut on there like that, what happens, Jared? Let's see. So you end up bottoming out to where you're not rotating on the threads anymore. But now if we back it off, we put our spacer on. That way we have no chance of bottoming out anymore. So turning the nut, same process as we're going to start. We're going to go through, put our snug tight condition on there with our full force iron worker.
Not full force.
Not full force. Do you think you can get it higher than that? Ooh, alright, I'm sorry. I did not mean to insult you. Because now we have to just turn the nut off without even. That's okay, you got it?
Okay.
Alright. So the basic turn of the nut, how many turns will we have to do for a 3/4 inch bolt, Jared?
So 1/3 of a turn.
Okay.
When the bolt length is not more than 4 times the diameter.
Okay.
Diameter is 3/4.
Mm-hmm.
So 4 times that's 3 inches.
Okay.
So this is a 2.5 inch long bolt.
Okay. So 1/3 turn?
1/3 turn.
Alright. So let's show them how we match mark it.
So you match mark it in 3 places. So you're going to match mark it on the end of the bolt. You're going to match mark it on the nut. You're also going to match mark it
on the actual plate itself.
on the actual steel itself to make sure your entire assembly isn't rotating.
Oh, so that way we know this isn't turning off of it or anything
Correct.
like that. We want our bolt to stay static and our nut just to turn out of the entire assembly.
So our pre-installation torque for a 3/4 inch bolt is going to be 29 kips. So that's the minimum that we need to achieve after this hits 1/3 of a turn.
Mm-hmm. So once again, if you look at your dials, a lot of them already have presets. So you come over here, we've got an A325 3/4 inch bolt. It says that 28, but we really have to take it to 29 for the bolt test, for the lot test.
Correct.
Correct.
After the required amount of turns.
Yes, after the required amount of turns. All right.
So 1/3 turn is going to be 2 flats here.
Just turn it. It's always nice to have a nice long cheater bar with you. All right. Let's see.
That's 1 flat.
1 flat. More, huh? There we go. So as you can see, from our starting point, we went over 1, 2 flats. Our bolt stayed at a static spot, didn't move at all in the assembly. And then we passed our minimum kip value. That bolt would be considered acceptable.
It's up to like 39 kips
Yep.
there.
All right. Just take a roll. Did you lose your socket there, my friend? Always wear your steel toes.
Inserted spacer, one washer. And this time we're going to do it a little bit differently to see if it'll still work.
You're gonna take it a little less on your.
Just going to barely snug it.
Also, not to the full. Not to your full ability.
Not
You're just taking
to my
it.
full ability. We're going to see if it still comes up to the minimum required value.
I like it.
We got the marker.
Oh, yep.
Match mark again. Use the same one on the steel.
Alright, you ready? Past it. Oh, right on it.
Yep, right on.
Right on.
So, with only snugging it to the 5 kips, we got it to right at 30,000. So that's still an acceptable turn of the nut.
Yeah. Doesn't take much to do snug tight, but you know, the snugger you get it at first, the little easier it is on the backside. And you know you're always going to hit your kip value that you should be hitting. Not a very hard test too. I mean, my scrawny little butt can do it. Most anybody else can do it around here. That'd be 2. Uno más. Alright, right there. Now for this one, Jared, let's just not even put an original load on there. Let's just finger tight it and see what happens. So you can see we're starting out at 0. There's basically no compression load. There's no tension on the actual bolt right now. We're going to go and do our 2 turns. Let's see where we're at. That will be the distance. That's 1. Just a smidgen more. There we go. That should be it. So as you can see, we came up. Put no original snug tight load on it. We just did finger tight, which is a very common thing that we find out in the field. Guys don't want to even pull out their spud wrench. They just want to take it and assemble it. And then we went our 2 flats, and we only came up to, what's that, about 16 kips or so?
16 kips.
Which
that
is
would be
well under.
a failed lot test. So it's not just a lot test, it's also a bolting crew demonstration.
Exactly.
So the bolting crew has to prove that their bolting procedure works in accordance with the RSCS, which is our guidelines for bolting.
So at this point, you know, it's time to sit down and, you know, talk about what happened. We know what happened in this instance because we did it on purpose. This is the time to educate, you know, people that maybe don't know the fact that they have to take a spud wrench out, get it all the way tightened as hard as they can, and then go through and do their turn of the nut on top of it.
So it goes right back to the same point.
Yep. So what's next, buddy?
We're going to do calibrated wrench.
Calibrated wrench. You want 3 more hex heads?
Yeah.
Okay, I will grab you 3 more hex heads. Alright, so calibrated wrench, let's talk about what the process is right now.
First part is you need to have a calibrated torque wrench. So this one's a little bit different. It doesn't go off of turns of the nut. It doesn't go off shearing effect. It goes off of torque values. So this is considered to be one of the least accurate methods to doing it. And because of that, you're supposed to do this test daily before you start any bolting operation.
So every day you would sit here and figure out what your daily torque wrench would be before you go up there and you start
daily
installing.
torque for installation.
And then it's a very common thing that we would use for, say, an arbitration on the backside, right?
Correct.
So say you go through and all the splines are all broken off the TCs, but you suspect that, you know, they were never snug tight, or they have other problems and they have a lot test failure or something like that. Now we would use the torque wrench to go through and verify that everything that is installed is actually installed correctly. All right, so what's the process?
So we're gonna, I have a clicker type torque wrench here. It's actually a little bit easier to do this test if you have a dial. That way you don't have to keep upping the torque on it for the new click. So what we're gonna do is we're gonna keep going until we hit that minimum 29 kips. We're gonna do that 3 times. And we're gonna average those 3. And then that'll be our
installation value?
Installation torque for the day.
All right. Are we gonna go through and put a snug tight condition on it?
We're gonna put a snug tight condition on it.
Okay. So what you could actually do with the torque wrench to begin with.
You could do a snug tight on it.
Right, I mean it's a wrench, this is a wrench,
yep.
Same thing. So where do you have your value set at currently?
I'm gonna start at 150. Let's see where that brings us.
So you always want to start lower, listen for the click,
Correct.
And continuously bump up.
Correct.
Until you get to your spot that you need to be at. So we get a click at, what's our torque value on that one?
150 foot-pounds.
So 150 foot-pounds, and we ended up at about 13 kips. So we know we're gonna have to bump it up a good amount to get it up to our spot that we need to be at.
180.
180.
Now we can go a whole lot.
Oh yeah.
210.
210.
$270.
Okay, so 270 foot-pounds, we're already at 21 kips.
300.
Oh, you're getting close.
360.
Just a little bit more. You're right at about 28 right now. There we go, 380. We passed over our 29 kips. So, A, we could say the bolt is good, and we can go to the next bolt in the series, and B, we could also give ourselves our torque value to go install for the rest of the day with that torque wrench.
Still need to do 2 more.
Yes, yeah.
I think it's average.
So A325s.
They can only be reused with the approval of the engineer.
Yes.
Anything that's hot dip galvanized or A490s shall not be reused. After it's been pre-tensioned, it's done. So if you're snugging up a joint and you tighten one up and it loosens another before they're all pre-tensioned, that's not considered a use. That's just part of bringing the plies tight. So in that case, you're allowed to keep going with it. But if you actually fully pre-tension it and you have to bust it loose for any reason, A490s and hot dip galvanization shall not be reused per the RSCS code. Black 325s can be reused, but only with the approval of the engineer. So you'd have to, if it's not written in the job specs, you'd have to submit an RFI.
So now, since you said a lot, you would have to then test every single lot and get that value for that lot, and then track every lot as it goes up into the steel, and then use that value that you get for each lot that goes up in the steel?
Correct.
Correct. It's a lot of work. Alright, you ready?
Yeah.
Alright. Alright, so we're going to back it back down. So once you get the first value, Jared, would you say you'd maybe back it down, you know, a little bit, and then try to shoot for that value again?
Yeah, it'll be close.
It'll be close? Okay. So I'm going to go through, I'm going to bump it down to, let's say, about 330. Let's see what that comes out as. So where are we at right there?
We're right at 25 kips.
Alright, so we're going to bump her up. Let's go up to about 360.
$28 kips.
28 kips. Go 370.
Yep, we're right there.
Right there, 370. So our last one was what?
380.
380. So that's why you do the 3 test, kind of get your range, and then you get your average out of that. That would be your average that you can take up into the steel you don't spend. Sweet. So that's 2.
2.
Back this guy down to 360. Alright.
Right at 30.
Right at 30, and that's 360. So that is calibrated wrench. Anything else you want to go over, Jared?
That should be it.
That should be it. Alright, well, everybody, thank you for watching. Please always remember, wear your PPE. As you saw, we had bolts kind of breaking on us, flying all over the place, dropping torque wrenches. It happens. Always wear your PPE. Please always use calibrated equipment, and see you next time.